So before start the actual project explanation, I request you please subscribe my channel. So you can see on the screen up till now I have uploaded more than 66 video on Raspberry Pi. The Raspberry Pi with IoT, that is all this video. Then also IoT with Arduino, all this video are 26. And recently we started the new series on the PIC microcontroller. Before that I also cover the project on the Python web application. So if you want to learn Python, IoT, Raspberry Pi, Arduino, PIC from the scratch and from freely, then please subscribe my channel, please support me. And the most important part is whatever the code I have explained, whatever the project I have created on this YouTube channel, all these projects are freely available. You no need to pay anything for this project. So just if only point is you should watch complete video and you should follow my process. So if you want to learn something from the scratch and freely, then support me and please subscribe my channel and please click on like button.
Hello friend, in today's session we will learn how we can design and develop a smart electronic voting machine based on Raspberry Pi. So before start the next part, I would like to tell you the practice simulation of the same project already explained in my previous video. The previous video link given in the description. Also you can see thumbnail of this thumbnail of that project on the screen. So if you want to learn the simulation part of the same project, then please watch that video. If you want to develop that project on the actual Raspberry Pi hardware, then please watch this video. Okay, before start the next part, I would like to tell you what will be the flow of this project. So you can see on the screen we have Raspberry Pi, we have LCD module, then buzzer, then switch module, and then camera. So basically when the voter comes and try to give the vote, so voter validity should be verified through his face. So you can see once the voter comes in front of the camera, the face is captured by this camera. Raspberry Pi run the face recognition algorithm, and once the face is validated, that is known person, then Raspberry Pi gives the permission to the voter, please give his vote. Then same process you can observe on the screen, like give the vote, validate person, unknown person, whatever the message from the Raspberry Pi you can also observe on this LCD. So once the voter give any vote to any party, let's consider we have three parties. One party is BJP, one party Congress, and one party NCP. So these three switch represent the three parties. So once the voter press this switch, then this buzzer will turn on, and this indicate that the voter already given the vote. Let's say in the next time same voter come to give the vote, then this face recognize this voter already given the vote. Then on the screen it will be show unknown voter. And let's say if any unknown voter again come which is not present into database, then also it will show the unknown voter. So this project is basically used to avoid the duplicate vote, also used to avoid the invalid vote. Also let's say after that if we want to check which party wins or not, so again the admin will come in front of the camera, then camera will detect the admin face. So once the admin face recognize, then here it will show winner name, whatever the party name. So admin has a right to show the party name. So this is the complete idea behind this project. I hope you understand the complete overflow of this project. Now I will tell you what I will cover in this video. So I will cover importance of each and every line from the code, and also I will cover how to connect each and every hardware to the Raspberry Pi, so you can design and develop this project by yourself. So before start the next part, I would like to show you the practical demonstration of this project, so that you will get idea what you will learn at the end of this video. Then we will see the hardware connection, and then we will see the programming part of this project. So please watch this complete video. Now you can see I have run the project and it shows the project name electronic voting machine. Now we will wait for the voter to come in front of the camera. So I will call the voter so that she will come in front of the camera, her face will be detected, and then our project will be start. So you can see on Raspberry Pi screen it is showing there is no face recognized by the camera. So it is only show on the screen like project name electronic voting machine. So once the voter come in front of the camera, then here also Raspberry Pi screen you will get idea about the voter name and his or her name, and also on the LCD it will show the give vote. So I will call the voter so that she will give her vote. Now we will call the voter to give the vote. Yeah. Now you can see water is coming in front of the camera. You can see the camera detect start working. So this slide is nothing but camera is start working, and here it is showing the valid person give vote. That means face is recognized. Now water will give the vote by pressing the switch. So you can see once the vote given, here it is buzzer return on, and now it is showing the unknown vote because unknown voter, because same voter try to give the vote, but now camera detect the same face and it is showing the unknown voter. So this is the first part. Now once the admin come in front of the camera, then it will show the winner name. Now I am itself as admin, so I will come in front of the camera. Come in front of the camera. So camera try to detect. So you can see camera detect, and it shows the winner name here. You can see it shows the winner name as a Congress because it detect my face and admin get access to show the winner name. Now I hope you understand the complete process of this project. Now I have only one person who support me to take the vote, so that I show only one voter. But in the last video I have also demonstrate the 3 voters. So if you want to understand 3 voter process, just watch that video. Same process, once the one voter give the vote, need again say a second person should come and she will give the vote, and again third person will come and then again he will give the vote. So like this you can add as many as database into our voter ID, and you can easily demonstrate this project with multiple voters. So I hope you understand the project demonstration. Now we will see the hardware connection, and then we will see the program part, and then we will see how to run this project.
So now I am going to tell you how I created this circuit, 0PC circuit by my own. So first of all, whenever you buy the LCD on the Amazon, you will get only this green LCD. You have to create this circuit by your own on 0PCB or on breadboard. So you can see the similar connection is here. So this is my main LCD. You can see 16 by 2. So there are 16 pins on this LCD. You can see 1 to 16. So first pin should be connected to ground directly, ground, and this is nothing but the 10K potentiometer. So you have to purchase 10K potentiometer. You can see this is the potentiometer. You have to purchase this potentiometer or any type of potentiometer which having the 10K value. You can also purchase this one also, or this one also, any potentiometer, this one also. Basically each potentiometer having the 3 pins. You can see these 3 pins, these 3 pins. So first pin is should be connected to the VCC of this potentiometer. Second pin is nothing but the middle one pin. You can see this one is middle one pin of potentiometer. So you can consider this middle one pin of potentiometer, or this middle one pin of this potentiometer. So connect the middle one pin to the VA pin, and the third pin of this potentiometer should be connected to ground. That's why VCC also connected to ground. Then VSS is nothing but the ground pin of LCD, that is the first pin. You can see this is my the ground pin of LCD, this is my VCC pin of LCD, common ground and common VCC. And then you can see till this part all the pins are same. So and this part is nothing but the controller pins. You can replace any controller at this point. So if you want to connect D4 pin, D5 pin, you can take it from this one, this one, this one, this one, and this is nothing but the these 3 pins. So and this resistor is nothing but the this one resistor, 560 ohm resistor, and this pin is LED negative pin, that is 60 number, is connected to ground directly. So connected to ground here directly. So this is connection I made by using this circuit. So I hope you understand how I created this circuit. So once you can design this circuit till this point, you can see till this one and till this point. So you can directly connect any number of LCD pin, any LCD pin to any controller, and this represent the controller pin basically. So you can replace any controller at this point. Whenever you require Raspberry Pi also, you can require Arduino also, you can just do the plug and play. You can just do the plug and play with this circuit with this point. So this is common VCC point, this is common ground point, and this one is your input point which reflect this this pin basically. Okay, if you don't want to make LCD circuit by yourself on the breadboard or on the 0PCB, then you can also buy the ready-made LCD board. You can see this is LCD board, you can ready-made buy. So you can see all the connection all already there. You have to just connect this 5 number ground pin RS enable D4, D5, D6 and D7 pin as per my explanation. So whenever I connect the D4 pin, you can also connect this D4 pin to Arduino, same D5, same D6 and then D7, same RS and 11. So this ready-made circuit you can buy from the Amazon. So you will easily find this circuit on the Amazon when you type this one LCD 16:2 display model, and you will find this one. So you can ready-madely buy this circuit and just plug and play this connection. So that is very easy then.
Now with this you can see at this side we have common VCC, at this side we have common ground. Then at this point you can see there is a input pin of this LCD module. So first pin is RS pin, then enable, then D7, D6, D5 and D4. So these are the output pins of this LCD. So we will connect only this pin with Raspberry Pi, the VCC and ground pin also with Raspberry Pi. So I hope with the zero PCB or breadboard PCB you can able to create this circuit with the help of circuit diagram I have shown on the I already shown on the screen. So please create this circuit diagram by your own by soldering the PCB like this one, or by using the by using the breadboard also. Okay, now once you get this circuit, once you create this circuit on the zero PCB, now we will connect this pin one by one with Raspberry Pi. So first point we will connect the RS pin to pin number 7. So for that we require the female to female connector. So I will connect the RS pin to the pin number 7. You can focus, this first pin is RS pin. Then I have connect this RS pin to pin number 7 of Raspberry Pi. So before starting the next part, I need to pay your attention here. You can see on Raspberry Pi, I by myself only created this page and paste this page on the Raspberry Pi pin, so that I can easily identify the pin number of Raspberry Pi. So even number pin come at this side and odd number pin come at this side, but with this page number I can easily identify the pin number of Raspberry Pi. So I hope you also do the same at your side, so that you can easily identify the pin number with Raspberry Pi. So first pin is this one, then second, then third, then fourth, 5, 6. So even number at this side and even number at this side and odd number at that side only. Okay, once you connect the RS pin, next pin is enable pin. So I will connect enable pin to pin number 11 of Raspberry Pi. So take this enable pin and I will connect this enable pin to pin number 11. Now we will connect the D4 pin from this PCB to Raspberry Pi 12 number pin. So connect D4 pin with Raspberry Pi 12 number pin. Okay, after that connect the D5 pin to Raspberry Pi 30 number pin. So D5 pin from Raspberry Pi connected to 13 number pin. After that D4, D5, D6 pin should be connected to Raspberry Pi 50 number pin. So D6 of LCD should be connected to Raspberry Pi 15 number. Then after that D7 pin should be connected to Raspberry Pi 16 number pin. So D7 should be connected to Raspberry Pi 16 number. So in this way we have completed the connection of LCD module. With Raspberry Pi. Now we will give the common ground and common VCC to Raspberry Pi. So this side act as a common ground and this side act as a common VCC. So ground pin of Raspberry Pi is nothing but the 6 number pin. So I will connect ground pin to Raspberry Pi 6 number pin. Then VCC pin of this LCD should be connected to 2 number pin of Raspberry Pi. So VCC pin of this LCD should be connected to 2 number pin of Raspberry Pi. So in this way we have completed the circuit part of LCD with Raspberry Pi. Now once we connect the LCD with Raspberry Pi, our next part is we have to connect this type of switch with the Raspberry Pi. So how to connect this type of tic-tac switch with the Raspberry Pi, I will tell you just now. So basically first we understand the switch structure. So switch having 4 pins, you can see this is the switch like this is the switch, and each switch having pin 1, pin 2, pin 3 and pin 4. So like this you can assume I place this switch like this, each switch having 1 2 3 4 pins. So 1 2 3 4 pins. So what we have to connect, we have to connect this pin to the VCC, that is 5 volt plus 5 volt. We have to connect this 5 volt, and this pin we have to connect to the resistor. This pin we have to connect to resistor, and from resistor we have to connect to ground. The resistor value is 1 kilo ohm. Okay, 1 kilo ohm is the value. Now between this pin and resistor point we have to take one pin outside, which is connected to our Raspberry Pi. So this is the simple circuit which is used for the switch. Again I will explain the same part to understand better. So this is the switch having 4 pins. So let's say this switch having 4 pins, 1 2 3 and 4. So this first pin we have to connect to the plus 5 volt of Raspberry Pi. Then from this pin there should be one resistor, and then should be connected to ground. Then this pin, middle of this pin, you have to take middle one pin from here, between this pin and resistor pin you have to take one pin, and this pin should be connected to Raspberry Pi. So this is the so this is the switch circuit. Now we have to perform this switch circuit on our breadboard. Now on breadboard we try to understand this part. So basically I will tell some basic idea of breadboard. We have this pin which is considered as a ground. We have this pin which is considered as a VCC. So this pin is a ground and this pin is a VCC. Between we have to connect switch between these two pins, like these two you can say row. So we have 4 row on breadboard. One row is this, one row is this, third and fourth. Now I will take switch like this. Then after that what I will do, I will place this switch. You can see this part I will place like this. Like this I will place. So you can see here the switch is connected. First 2 pins are this row and second 2 pins are this row. So in this way you have to connect the switch. Okay, with the same way I will take the another switch. I will take this switch like this, and again this row and this row, in between this row I will just place this switch like this and paste here. And then again I will take the third switch, and same way this row and this row I will just place like this. So you can see in this way you have to place your switch. Then after that what we have to do, this part is considered as a VCC. So as per our idea, this pin is considered as a VCC pin. So this pin, what I will do, I will attach to the VCC here, about to this pin like this. So you can see what I have did. I have take this switch, this pin, and connect it to a breadboard this row. So again same switch, second switch we have to connect this row, third switch we have to connect to this row. Like this you have to perform. I hope you are understanding what I am telling. So again same part, switch this pin, you can see switch this pin I will connect to here. So very basic and easy circuit. Then switch 3 pin, third pin, you can see third switch connect to this row like this. So up till now what we have connected, our upper part of switch, this pin we have connected to VCC. Now this switch, this row we will connect to Raspberry Pi VCC later. Then after that we have to take the resistor, 1K resistor. Okay, 1K resistor we have to take and switch this pin. You have to connect from this resistor, like here I have connected register. Here I have connected register. Like register is connected here, and then one register pin I will place into this row. Like this you can do. So again try to understand here. This row act as a switch pin, okay, this pin. So I will take register from here, and second point of register is connected here. And this pin later will be connected to ground, and you can see there is some gap between this register and the switch pin. So from this gap we will connect to Raspberry Pi pin later. So likewise you have to repeat your operation 3 times because you have 3 switch. So again second register with the second switch and then connected to second row here, and like same way 1 kilo ohm resistor, third row switch and connected to third row like this. So just focus here, each switch pin connected to resistor, and this row should be common, you can see common to the all resistor. Same this row should be common to the all VCC. So you should not use this row, this row, this row, this row like this. You have to use only single row and single row whenever you are connecting to the resistor. So in this way we complete the switch part. Now we have to connect this switch to our Raspberry Pi. Okay, so first part is first we have to take the VCC pin. So I told you this point is considered as a VCC, so I will connect this pin, and already number 4 or number 2 act as a VCC. So what we have done earlier during LCD connection, you can see this is my LCD connection. So what we have done, we have taken 2 number pin from Raspberry Pi to LCD common VCC point here. So whenever I require the VCC, that is 5 volt, I will take from this LCD pin. So like this you can do, or you can easily from your breadboard also there should be common VCC, you can adjust, and from that VCC you can give the common VCC and common ground pin. There is no issue. So let's say if I want the VCC pin, what I will do, I will take LCD pin VCC from here, because it's common, eventually it's coming from the Raspberry Pi only, and then I will plug to switch VCC pin here. Okay, so like this. So another point is ground pin. So again ground pin, what I will do, I will take the common ground pin, that is 6 number pin from the Raspberry Pi, and connect it to common ground to here, LCD common ground, you can see. So whenever I require ground, I will take from this common ground. So here I will require the common ground for the switch. So I will plug here in this row, and I will just connect this ground to the common ground. You can see this one here. So eventually this ground, Raspberry Pi ground is connected here, and then again I have given ground to ground here. So this is basic circuit, like we require common ground and common VCC. Now next point is, once we have the VCC pin, common ground pin, again I will zoom in to the switch. So you can see we have taken the common ground, common VCC here, common ground here. Now what I told you, in between register point and the switch point, in between register point and switch point, we have to take one pin which connected to Raspberry Pi. So this between here I will take one pin, and this should be connected to Raspberry Pi 29 number. Okay, same switch 2 in between register and the switch 2 pin should be connected to Raspberry Pi 31 number. Then after that switch 3 register and the switch 3 between pin should be connected to Raspberry Pi 33 number, like this. So switch 1 is connected to 29 number, switch 2 is connected to 31 number, and switch 3 connected to 33 number. So I hope you understand the basic idea how to connect the switch with the Raspberry Pi. So up till now we cover the switch and LCD. You can see up till now we have covered the switch and LCD circuit. Now we have to cover the buzzer part. So buzzer part I will show in 5 minutes. Now our last part is remaining, that is buzzer. So when you purchase the buzzer, there you can see there are two pins to the buzzer. One is a red pin which is considered as a positive pin, and blue is nothing but the negative pin. So very easy and simple circuit for the buzzer. So negative pin, you can see this is the negative pin of the buzzer. So I will connect to negative pin of our circuit. So wherever I found the negative pin supply, then I will connect there. So on breadboard also I found the negative pin supply, because already we have taken the common negative pin here. So I will connect the common negative pin of buzzer to here. So it eventually it's connected to Raspberry Pi 6 number pin, which is the negative. Now after that, buzzer positive pin. So this is the buzzer positive pin that should be connected to Raspberry Pi 35 number. So this is the positive pin of buzzer, and that should be connected to Raspberry Pi 35 number. So just connect like to the Raspberry Pi 35 number here. So very easy and simple circuit of buzzer that we completed. Now the next part is camera. So you can see this Logic camera I have purchased. This is the Logic camera. So you can also purchase Raspberry Pi camera also, any camera, but for accuracy I purchased this Logic camera. So this Logic camera has this USB port. So simple, what I will do, I will just connect this USB to Raspberry Pi USB here. So like this you will connect this Raspberry USB camera to Raspberry Pi. Now let's understand how you can run this project on your Raspberry Pi. So very important part is you require Raspberry Pi Noobs OS in your laptop. So if you don't have the Noobs OS in your Raspberry Pi hardware, then how to install that Raspberry Pi, how to install that Noobs OS into your Raspberry Pi hardware, that I already explained in my first video. You can see thumbnail on the screen. So please watch that video and try to install the Noobs OS in your Raspberry Pi hardware. The second part is you require the electronic voting machine Raspberry Pi hardware project folder in your Raspberry Pi memory card. So first download this folder from my web page. So web page link given in the description. There you will find one download button, and from that you can download this file. So this file will be in zip folder. So you have to unzip that file, then you will get all these files. So this is first step you need to do at your side. Second most important part is you need to install some library in your Raspberry Pi. So in the notes I have already provided which library you need to install, OpenCV and face recognition library. So how to install that library I already told in first video of face recognition project. That video thumbnail you can see on the screen. So if you don't have this library in your laptop, please watch that video. There is one chapter how to install this library in your Raspberry Pi. Please watch that chapter and try to install this library in your Raspberry Pi. Okay, these are some basic steps. Now the most important part is you need to create your database. So how to capture the image, you can use this file capture image from the camera. So once you double click on this file, then this program will be open and you can run the program, and after that you can give your name, and after that you can capture your image, and that image will be stored into your particular folder with your name. So this is the very first step. If you want to understand details explanation of this code and detailed step, then please watch my smart attendance system project. So in that project I have already explained how to use this capture image from Pi in detail. I will not explain that step again because it will take a lot of time. The thumbnail of that video you can see on the screen. I hope you have watched that video, and from that video you understood how to capture the image, and you can just run this code and you can able to capture the image and store your database like this with the name. Then after that, second program you need is face recognition code. Same code I have already used in the smart attendance system project. Just double click on this program. I will just quickly show you what step you need to follow. You can see whatever the image you captured, you have to just rename that image with your database name. Then after that, here also you need to rename your image as per your reference. Then at the end you can see here in the program, here you can see this name Rahul is nothing but the admin. So if you want to give your name, you can give admin name as your name, and then it will give the admin access. So here you can see name is equal to Rahul. So instead of Rahul, you can change your name so that you will get the admin access. So this is some basic step you have to follow so that you will get admin access, and you have to store the data into your Raspberry Pi. So again I repeat, if you want to understand exact correct each and every line step process of how to store the data into your Raspberry Pi, please watch my Smart Antenna System project video. In that video I have in detail explained how to use these two code and how to create the database and where to change the name. So in this video I just told you like where to change the name. This is very important part. This here you have to change the name, then here you have to change the name as per your database, and then here admin name you have to change as per database. Here you can see this name you have to change. So this basic step you have to follow so that your project will be run. So once you change the name, admin name, and with your database images name, all things here, how to run the code, just click on this run button. So once you click on this run button, it will take some time to run the project, then your camera window will be open here, and after that your project start working. So I will just show you one demo. So let's say if everything is okay, then you just click on this run button. So once you click on this run button, you can see here the camera start recognizing. So wait for some second, and side by side I will tell you very important part is I am using the USB camera, so that's why I have given here 0. If you are using Raspberry Pi camera, then you can use 1. If you are using so this one you can change as per your camera. So if you are using USB, then you can give 0. So this detail step I have already explained in my Smart Antenna System project. So you can see once the project start working, then your camera will be open and you can see project start working perfectly. So I hope you understand the basic step. Now your question may be, why did you not explain the each and every line of code? So basically I have already explained each and every line of code in my Proteus simulation video. So if you want to understand each and every line of code, please watch that Proteus simulation video. And second part is the only difference between Proteus simulation and hardware simulation is that here after recognizing face in Proteus simulation, we are starting the Proteus software here, but we are combining the Proteus software and Python software in the same program in hardware part. So all the things are exactly equal. If you watch that video, you will get understanding about each and every line of code. I hope you understand how to run the project, how to connect the hardware with Raspberry Pi, and yeah, if you like my content, please click on like button, please subscribe my channel, and please support me. Thanks for watching this video.